Now, bubble sort. So actually what we are going to do in bubble sort is that we are having an array of haphazard values. Now what we are going to do is to um, put those values in an order. So the default order that we are going to discuss is ascending order of anything. Remember, if it is number, it is always an easy thing to understand that number is going from the lower number to the higher number, that is ascending, and if number is coming from higher number to lower number, then it is descending. But if it is non-number, for example, it is text, or if it is characters, then sorting order should be seen as per their ASCII values. Remember that all capital alphabets come before lowercase. Capital A starts from 65 and ends at 90, which is Z, and small letter A starts from 97 and go up till 122. So all the values which are from capital A would appear first in ascending order, and all the values which are starting from small a will appear later. So we can also understand it in terms of that all capital letters have priority in ascending order over the lower letters, and all the names starting with capital A would appear first, and capital Z would appear later, and after capital Z, small a names will start appearing. This is all because of their ASCII order. So what we actually are going to do is, let's say if I have got an array name which has got 1, 2, 3, and 4 values. First value is Z with Zafar, then we have got A with Ali, and then we have K with Khan, and then we have Bilal B. Now we want to sort it. This is unsorted, and then what happens that if we have sorted, it would become Ali come first, and then Bilal, then Khan, and then Zafar. So this transition from this to this means unsorted to sorted. This is what we are going to do. All right. So this is actually can be done using several ways, but over here in AS, there is just one algorithm prescribed by CIE, and that is called bubble sort. So we are going to discuss bubble sort. So now first discuss what is bubble. Let's suppose that we have got two variables, A, which is having a value of 15, and let's say another variable B that is having 80 in it. Now what I want A to become B, means A's value should be 80, and B to become A means B's value should become 15. Now if I go like A is equal to B, that means that A's value will become 80 and B remains 80. And then if I say B is equal to A, it means they both are 80 and 80. What I have done, I have made a mistake that I actually overwritten value of A. And if I go with like B is equal to A, then it means that B would become 15. And then if I write A is equal to B, A's value will also be 15, because B, we made B earlier 15. So this cannot be done this way. So what we have to do, this is a wrong thing. What we have to do, we have to employ or use an extra variable, and let's assign that value of A to that extra variable. This is, let's say, a temporary variable. We used a temporary variable. We assigned the value of A to that temporary variable. So now X is equal to 15. Then what we do, we make A is equal to B. the value of A will now become 80 as B is equal to 80. And then what we do, we make B is equal to X. As we preserve the value of A before making it 80 to X, now the value of A will become 15 as X was 15. So using an extra variable, X is equal to A is equal to B, and B is equal to X, this particular way is correct. And this is called bubble method. This way we can employ an extra variable, an additional variable, a temporary variable over here by the name X. And we once we make use of an extra variable, we actually tend to save values which we missed earlier here because original value got overlapped. Now X is having the value of A, then we make A is equal to B, and now A has 80, although we have overwritten A because it was 15, but since before overwriting A with B, we saved the value of A to X, which is a temporary variable, and then we assigned X to uh, B. So now B has got the value which X had now. They both are conveniently exchanged. So this is called bubble. Now let's let's see that how we exchange two different elements values in um, an array. Obviously, we also gonna use the same technique. So let's say I want to exchange this Zafar with Ali. All right, so what I would do, the name of the variable is name. I mean, the name of the array is name. So let's say I would write name X is equal to name1 is equal to name 2, and name 2 is equal to X. That is how what I would do, that I will make this position 1, 2, 3, 4. When I say X is equal to name1 would have Zafar in it. So the value of X will become Zafar. Then I say name1 is equal to name2. So it means that Zafar will be gone, Ali will take over it. And then name2 is equal to X. So X was Zafar. So that is how we exchange two values. Now, as we know that in array we can use variables as um, subscripts. So let's make use of that. What will happen that I will put this whole thing in a loop for I is equal to 1, 2, 3, and I will make this name I, X is equal to name I is equal to name I plus 1, and name I plus 1 is equal to X, and then next I. Now what is happening? What is happening is that I as index is 1 when it starts the loop. X is equal to name 1. X will become Zafar. Name 1 will become name 2. I plus 1 is 2. So this place will be filled with Ali. Zafar will be overwritten with Ali. And then name 2 becomes X. X had Zafar. So Ali is now in position 1 and Zafar now is in position 2. Afterwards, I become 2. Now, this is Khan and this is Bilal. So what has happened that Ali has come here. This is Zafar. This is Khan. This is Bilal. Now I is 2. So x is equal to I2. The value of x is now Zafar. I2 is equal to I3 because I is 2, so I plus 1 is 3. So this Zafar now become Khan and I3 is equal to X, which was Zafar. So it has become now this. So this Zafar has been removed. It has come down here and Khan has gone up. Now I becomes 3 this time. So X is equal to I3. I3 is Zafar. I3 is equal to I4, I plus 4. So this Zafar has now become Bilal. And then I plus 1, X is 3. Remember, I plus 1, 4 is equal to X, which is now Zafar. So now the array's position has become like this. Ali, Khan, Bilal, and Zafar. You need to understand two things over here. Number one, that loop was not until 4 for the reason that we have been using I plus 1 over here. If I go up till 4, that means that I plus 1 4, I plus 1 will become 5, 4 plus 1 will become 5 at the end of the loop, and there is no fifth element. That is a permanent error, that is runtime error. If such thing happens that the program tries to access a location in the array, an element in the array which does not exist, then the program crashes. So you need to understand that we have to run the loop until here because we will be matching these two values and we don't have any value further, so this loop will always go upper bound minus up to upper bound minus 1 location. Now we don't want to do it if it is not in favor. What does that mean? It means that uh, we will only do it if the first value is greater than second value. Means since this Ali is smaller than Zafar, these two should not get exchanged. But this Zafar is greater than Khan, so these two should get exchanged. This Khan is greater than Bilal, so these two should get exchanged. So what we gonna do is I'm gonna put an if condition here, which will be like if name I is greater than name I plus 1, then I will do it. Otherwise, I won't. Then do this and if. So now what is happening that at every loop, system is checking if the ith position is greater than I plus 1 position. If it is true, then only this loop is, this exchange, bubble exchange is happening. So let's do it with these value now. Let's see if it is all working properly. Let's say these are our original values: Ali, Zafar, Khan, Bilal. Ali, Zafar, Khan, and Bilal. For I is equal to 1 to 3. So let's say if the value of I is now 1. So if it is checking if name 1 is greater than name 2, if Ali is greater than Zafar, no, it is not. So it will go down to, and if next I will become 2. Now it is checking if name 2 is greater than name 3. If Zafar is greater than Khan, yes. Then what will happen? That this Khan will come up and this Zafar will go down, rest 2 remains the same. Then I becomes 3. Now it is checking if name 3, which is now Khan, oh sorry, Zafar, name 3 is greater than name 4, which is Bilal. Yes, that is true. So this Bilal will come up as this Zafar goes down. This Bilal now will come up and this Zafar will go down. Now what will happen? The final value will be Ali, Khan, Bilal, and Zafar. Now you need to understand that this loop has ended, but the thing is that this array is not yet fully sorted. So we have to run this for next once again. Now for that we have to put it in another for next. So we have to run this for next over here until the whole array is sorted. So let's say we have got 4 values in the array. Let's make another loop which goes like for j is equal to 1 to 4 and next j. Now second time, as I told you earlier, that for every outer count, there's a complete cycle of inner count. Now in first cycle, this is what has happened. Means when j was 1, this has happened. Now this is the current condition of the array name. After first loop, Ali, Khan, Bilal, and Zafar. Before first loop, it was Ali, Zafar, Khan, Bilal. Now, let's say j is 2 now. J is 2. So now for second iteration of j, the whole loop of I will be executed. Now for I is equal to 1 to 3. So if it says that if Ali is greater than Khan, no, this loop ends, I becomes 2. If Khan is greater than Bilal, yes. In this case, Bilal will come up and Khan will go down. Now this is the third iteration. If name 3 is greater than name 4. If Khan is greater than Zafar, no, it is not. So only one exchange has happened. This inside loop is now finished. So this is the current condition. Ali, Bilal, Khan, and Zafar. This has now been sorted, but still outside loop would go for another time because this is the fourth time we have written this program this way that this will happen as many times as the number of elements here. So if I is equal to, for j is equal to 4, this would be checked once again. I is 1. So it is checking if Ali is greater than Bilal, no. I becomes 2. If Bilal is greater than Khan, no. I becomes 3. If Khan is greater than Zafar, no. So in any of the inner iterations, since the whole array is now in ascending order, nothing has happened, but still J loop worked. So this is regarded as an inefficient sorting algorithm, but this is what we meant by bubble sort, that we have sorted the whole array in ascending order. That is how the bubble sort works. Now let's revise it. So first thing I told you, let's say, is about the array. So let's say this is an array whose name is to be sorted, TBS, which has got 5 values. The lower bound is 1, the upper bound is 5. All right, so now we will represent this subscript or index with I in this loop. So what is happening? We are actually uh, sorting an array which is character data type and it has got values A, B, C, D, E. It is already sorted. All right. So from my perspective, it will never be exchanged. Any of the value in this array will never be exchanged. Anyways, so we have used another loop outside this. Uh, as you would have noticed in previous slide, that when the first time we ran this loop, the largest value has come down. We checked these two, nothing has happened. We checked these two, Khan came up and went down. And then Zafar and Bilal, when they were checked, Bilal came up and Zafar went down. So whatever the first value is, sorry, whatever the largest value is in first of the loop, means outer loop cycle, it goes to the end. So we don't have to check these values up till that last element. Now we have to start from, as we know that when the first time inner loop goes on, the largest value will come down. We start from the largest upper bound minus 1 to 1. When we go back, we have to put this loop this way, upper bound to 1, step minus 1. So we will go from 4 to 1. So outer loop will go from 4 to 1, because we know when we will check from up inside the loop, we have put it this way that I is equal to 1 to j. So j starts from 4. So it will go from 1 to 4. And in 1 to 4, the highest value e will come down. Then when it goes out, it will become 3. So for j is equal to 4 to 1, now the j has become 3. Now this loop will go from 1 to 3. When it will reach to 3, the value up to 4 will be changed. And that is how it will go further. Now, I have used a flag over here. So this flag, like in last slide, I have shown that although before the last time outer loop started, the array was actually sorted fully, but still the loop worked. And that is why I qualified that algorithm as inefficient. I disqualified, in fact. So this particular flag will help us. So before the inner loop starts, we made this flag false, was swap, was swap, was false. And if any of the swap happens, then we made it true. So how it works, whenever there is a single swap, it has become true. And if this was not the case, then was swap will remain false. So when the whole inner loop worked and was swap remains false, it means not a single exchange has happened, because the array is already sorted. So if it is sorted, it was false, it remained false, there was no single swap, then we don't have to run outer loop any more times, we have to get out. So here we will use if was swap is equal to false, then exit for. So it is simple. The array that we are given might have few values to swap before it becomes in ascending order, or it is already in ascending order. So we may have the best case, it is already in ascending order. We have a mixed case when few of the values will get exchanged and it will be in ascending order, and we have the worst case when every value has to be swapped. It is jumbled, most jumbled array. So at any given time, at any given point, if the array is already, let's say, if the array is already sorted, outer loop will work once and inner loop will work once, and then we would have, because of this flag idea, that nothing has been swapped, so we will get out. If it has happened out of outer four loops, it has happened in second loop, then the third loop will not be executed and system will get out. If it is in worst condition that all the values are jumbled, then it will go up to the last loop possible and it will be sorted. In any case, the whole array will be sorted. Now, what you have seen over here, that in outer loop we have gone from upper bound -1 to 1 in reverse order, and for inner loop we have gone from 1 to the upper loop's current count, and we have used a flag inside it. Now it is fully efficient because we have made use of a flag which would not let this loop work any further if the array in the middle or in the start or at any point of time during the execution of the program is sorted. And secondly, we know that in every inside loop, and at every inside loop's end, the highest value comes down, and afterwards when the inside loop works one, the value before it, second highest value, comes on top of it, and then the third highest value on top of it. So it means that when we know that inside loop when works once completely, the highest value comes down, so we don't have to check it fully, the array. So we start off from the upper bound -1 position because we know that upper bound's position will be having the highest value in it, and then we go further because the highest value is not needed to be checked again. So last thing, as we know that we have subroutines in place as well, so whatever the procedure that you are going to write should be having its own subroutine. Most of the questions answers that you are expected to write should be in their respective subroutine. So this subroutine is called bubble, and it receives the array needed to be sorted and the upper bound. So this array is to be sorted has been received as parameter in this procedure bubble, and another parameter which tells that how big this array is. So I have made this subroutine fairly flexible, which can sort any of the array from top to the bottom. All right, any sized array from top to the bottom. So here we have used this parameter and the array which is received. Now this is inside loop which works from 1 to upper bound -1, whatever the upper bound's value is. I'm going to introduce another option where inside loop is in for next, but outside loop I'm going to change the loop to while. Then I used the flag swapped, made it true, and then I have written that while swapped remains true. And before starting inside loop, I have made swap false. So if there was a single swap happened, I made the swap true. When it gets out of this for next and it reaches out to end while, and while checks that if it is true, then it works. Since there was a swap, so there's possibility that there are further swaps. So it works until it is true. And before starting inside loop, we have made it false. So if in inside loop there is no swap happened, swap will remain false. So and while we'll check that if it is true, it works. If it is not true, it is false, then it gets out. So this is another option that we have. Again, we have to put it inside an array. Oh, I mean the subroutine. Now, this is from the book. This is for the first inside loop. What has happened that if you see all these values, 98 is the highest value. This is inside loop, first inside loop. There are two loops, outside and inside. For every outer loop, there is a complete cycle of inner loop. So now these two values are compared, no exchange happened, no swap. Then these two values are compared, no swap. Then these two values are compared, 7 came up, 98 came down. Now you need to understand that this 98 is the highest value. So when the inner loop ends, this 98 gets down to the last location. So outer loop will go from this location to this 1, 2, 3, 4, 5, 6, 7. So outer loop starts from 6 to 1, and inner loop goes from 1 to 6, because when it is 6, it is checking 6 plus 1, 2 as well. So now this is one inside loop finished. Now the value is 25, 34, 7, 41, 19, and 15. This will be checked, and then 41 will come down, then 34 will come down, then 25 will come down, then 19 will come down, and that is how, when the outer loop finishes, whole array is sorted over here. This is another perspective from the book. They have made n maximum index minus 1. Maximum index is upper bound. And they ran the loop from I, for I is equal to 1 to maximum index minus 1. And for every I, there is a complete cycle of j. J goes from 1 to n. N is maximum index minus 1. And the same bubble sorting happens, and the loop works again and again and again. And for the outer loop, and n's value goes down. So they have not tied up this countdown with the outer loop, rather they are counting their value down by themselves. This is another way, though it is not very efficient or learnable way, but it works as well. Now this is the program. This program has got two subroutines, main and bubble, as we made earlier. So we made one array, this array with 5 values, 5 elements, and as character. Then we ran this program, and the whole array is read. I mean, all 5 values were read from the keyboard and assigned to array. This is population. Then with that input values, whole array populated, is sent to this subroutine. Now you need to understand, when the array is being sent as a parameter, it appears like a variable, because we don't have to put any parenthesis here or the upper bound in it. It is all just like another parameter. So we sent this array as parameter to this subroutine, which is a procedure bubble, and the upper bound 5. So this array is now received in to be sorted array by reference. By reference means it is now received with a pointer, means whatever that is happening over here with this to be sorted is actually happening with this array over here in the main subroutine. They both are referring to the same array with different names, because it is being received as by ref. And then upper bound will be receiving 5. So was swap is equal to false. It is boolean variable. And then j goes from upper bound, whatever upper bound 4 to 1, step minus 1 was swap made false. And I goes from 1 to the value 1 to 4 for the very first time, then 1 to 3, and all. WhatsApp was made false, and if during the inner loop there was any swapping happened, then WhatsApp was made true. Otherwise, WhatsApp remains false. If it remains false, it gets out, and control goes back to the main subroutine. And if it does not, after the complete sorting of the array, it goes back, and there it outputs the whole array to the screen. So these are the values which we have put when the input was taken 5, 4, 3, 2, 1, and then output 1, 2, 3, 4 was done. Number of loops that worked was 10. How did we count it? Actually, what I did is I put uh, a variable inside the loop so that it could count that how many times the loop has worked, the inner loop has worked, how many times, how many runs it has made. This is A. So this A was also output. So it was so badly messed up that all of the array was actually sorted in 10 loops. So I tried solving bubble sort, I tried explaining bubble sort. Hope you would have some idea from your lectures before. So it has refreshed bubble sort. Excuse me. Now, whatever that is required by these task 2.1 and task 2.2 is now discussed. Let's solve few of the past paper questions so that the idea of every sort of question that may appear for this array could be understood properly. Let's start in reverse order, latest to oldest questions. So let's take this question from May, June 2018. This is question number 5, I believe. This question asks, a golf club holds information about its members. When a member completes a round of golf, their score is stored along with their membership number and the date of the round. Explain why the club stores these data in a file rather than an array. Now, this is another important thing to remember, that array is a data structures. Data structures are in RAM. So they are not permanent. As soon as computer is shut down, the data in the RAM is gone. That is why all the files that we create in any of the software, we save it first so that it remains. And when we restart the computer, we actually hold it. I mean, load it back. So now, because we need to have this data permanently, we have to save it over the disk in a file. An array always resides inside the RAM, and it is not permanent in nature. That is why we the club stores these data in file rather than an array. Let's take this question from May June 2018, 9608 P22. This question is, this question says, a golf club holds information about its customers. When a number completes a round of golf, their score is stored along with their membership number and the data of the round. A program is to be written to store and process the score information. The information to be stored is formed into a string as follows: membership number, date, and score. The program designer considers storing the string in either a 1D array, whose name is round score, or as separate variables for each round. For example, round score 1, round score 2, round score 3, and so on. So describe two advantages of storing the string in 1D array rather than a separate variable or as separate variables. So this is simple, that uh, we don't have to describe, we don't have to declare so many variables, but a single 1D array of the same data type. All operations, that is second advantage, like searching, sorting, populating an array becomes very easy. Other advantage may be more efficient coding, less declaration statements needed, as this says, access of individual elements using index. Um, Code is easier to understand. Obviously, we would have less to write and less to understand then. Now, another question. This is question number 6 from the same paper, that is May-June 18 question 6. Individual elements in a 1D array are referenced using an integer value that is used as subscript to the array. Uh, Give the technical terms for the minimum and maximum values the subscript may take. We know about it. Minimum value is called lower bound and maximum value is called upper bound. Now, a 2D array picture, as we can see, I told you that 2D array is array that has more than one columns. So these are column 1, column 2, column 3. As we can see over here, there are 1, 2, 3, 4, 5, 6, 7, 8 columns and 1, 2, 3, 4, 5 rows. So these are columns increasing in this order, and then we have got rows increasing in this order. So it says a 2D array picture contains data representing a bitmap image. Each element of the array, this is one element. This is one element, mind it. So this is one element, second, third, fourth, fifth, sixth, seventh, and eighth. Each element of the array represents one pixel of the image. The image is grayscale encoded where the value of each pixel range from 0 to 255. As you can see over here, that this box represent 80. So this is 80, this is 255, and similarly this is 120, this is 80. You can relate it. These all can be related. So pixel ranges from 0 to 255, 0 which represents black and 255 represents white, with intermediate values representing different levels of gray. A graphic program needs a procedure flip to flip reflect the image. An example of the image before and after the function is this. For example, this one, this particular element will be flipped in here. This one will be flipped here. And similarly, you can see that this side is flipped in here. This side flipped in here. So these values are being flipped from left side to the right side. So you can imagine what we are going to do. So there is a procedure flip to flip reflect the image. An example of the image before and after the function is this. All right. In pseudocode, the array is declared as follows. Declare picture 1, 5, 1, 8. So we can see that this is number of rows 1, 5, and then this is number of columns 1, 8. Now it says write pseudocode to implement the flip procedure, assuming that picture is a global variable. Assuming picture as a global variable means that this array is available to this procedure without any hurdle. So now let's see what we are going to do. First of all, it's a procedure. So let's write procedure flip. All right. So now we are going to use the same strategy as bubble sort. What we are going to do, we are going to take this value and keep it in temporary, and then copy this value to pictures other side over here, and then making other side equals temp. We have to flip. We have to flip. So this 255 will go there, and this 80 will come over here. So that is how we're going to do it. So we need to understand that these are 1, 2, 3, 4, 5, 6, 7, and 8 columns. So what we actually are doing, we are running a loop from 1 to 5, means for every row and then for every column. All right, and then we are swapping these values. So let's see how. First of all, I'm not declaring any variable. As soon as we require any variable, we will do that. So let's say for row is equal to 1 to 5. You can use an arrow as well that I actually don't use, but that does not make any difference. And then what do we need? We need to declare row as integer. Then we need for column is equal to 1 to 8. As we know that there are 1, 2, 3, 4, 5 rows, and then 1, 2, 3, 4, 5, 6, 7, 8 columns. It means that we are going to run a loop for every row, and within a row every column. All right. So uh, then what we do? Then we take a temporary variable first. Temporary is equal to picture, that is the name of array, row comma column. So now we have a value, this value, okay, and we have put it in temporary. Now we have to have a check so that we could move this value in here. We could move this value in here, and then we will swap this value with the temporary value. So what we are going to do is, now we write picture row comma column is equal to, we have to actually run it so that it becomes equal to this 8. So now itself it is 1. All right, column is 1, which is I, or sorry, row, I mean column. All right, so we will make it equal to picture same row comma 9 minus column. Now why 9 minus column? If we are at column 1, then 9 minus 1 will become 8. If we are at column 2, then 9 minus 2 becomes 7. If we are at column 3, 9 minus 3 becomes 6. If we are at column 4, then 9 minus 4 becomes 5. If we are at column 5, then 9 minus 5 becomes 4. All right. So that is why you need to understand that if we have reached 4, then we are actually going to overlap. So this 8 would not be 8, rather it would be 4. All right. So now, since we are at column 1, 9 minus 1 will become 8. So this will become equal to 8. Now, picture row 9 minus column is equal to 10. We swapped it. All right. Now, end column, end row, and we need to have row, column, and temp declared as integer. That is how the question will be solved, and then we have to finish the procedure and procedure. All right. So let me revise. We have to run this procedure from values in 1 to 4 for every row, and then we will be swapping this uh, column from the far end, this column with this column with this column with this. All right. So what we do first, we take it in temporary, then we will be making it equal to this, and then we will be making equal to temporary, and these two are swapped. And then we go further, we do this operation with this, then this, and afterwards we start with second row, then third row, then fourth row, and then fifth row. That is how it will work. Practice it. Basically you would know it better. Look into the marking scheme for the same paper and try it yourself. Hopefully, uh, you will get it. Now, let's see a question further. This is 8-mark question. So that's about it for this question 6. This is a good example of array manipulation. Let's take another question. So let's explore another question from October-November 2018, paper 2-3. This is question 3. It says an array contains 100 integer values. An algorithm will find the maximum and minimum values stored in the array. A programmer has started to write this program using a conditional loop. Name a more appropriate loop structure for this algorithm, for this task, and justify your choice. So now name should be for next loop. I explained this that the best loop for this is for next loop, as the lower bound and upper bound are always known, and we also call it count controlled, count based or controlled, count controlled loops. Now justification should be lower and upper bounds are already known and which means number of loops will be fixed. Um, that's it. I think that would be good enough. Now it says outline the steps the program will need to follow to implement the algorithm. And what is that algorithm? A programmer has started to write this program using a conditional loop. An algorithm will find the maximum and minimum values stored in the array. Now, let's first write the algorithm and then we will decide that how do we actually uh, describe it. Whatever. First of all, we have to have maximum and minimum. Declare max comma min as, no, we don't have to write as, rather we have to put colon here as integer, and then we will make maximum is equal to, what's the name of array? An array contains 100 values. So there is no name given. So let's call it number array. Number 1. We made this maximum value equal to number 1, and we will also make minimum value equal to number 1. So the first value is maximum and minimum. Then we will run the loop from first location to the 100 location. For count is equal to 1 to 100. And what we are going to write is, no, not from 1, rather from 2, because we have taken first value already. So now we will write if num count is greater than maximum, then maximum is equal to num count. Same we will do for minimum. If num count is less than minimum, then minimum is equal to num count. Next count. And then we are going to output maximum is equal to max, and then output minimum is equal to min. So see, this is quite simple algorithm like O levels, which actually needs you to first of all declare two variables, maximum and minimum, and then we have to run a loop. First of all, we will make maximum and minimum equal to the first value of the array, which is at the lower bound. And then we will start from second to the 100th element of the array, and we will compare every element of the array with the maximum. If the value is greater than maximum, it means we need to set the maximum now to the current value. If it is not, then we leave it. Similarly, we will check if the value at the array's current location is less than minimum, then we will update our minimum. And the whole thing will go on. And once we get out of the array, we will have our maximum and minimum output. So we have to outline the steps. Now, see, I'm going to write steps. Number one, declare minimum and maximum variables. Make minimum and maximum equal to first element of the array. Number three, run a loop through the array, compare every element with maximum and minimum, update maximum and minimum if they are larger or smaller than the current element. So that is how you will answer it. There we go. The whole question is answered now. So let's see what's next question is. Next question is a different question, but it has got array in it. So let's see the scope of array, the number of dimensions of this array, number of dimensions of this array. Number of dimensions of this array is actually 1 to 100 rows and 1 to 10 columns. So 100 rows and 110 columns. This is the dimension. Now, let's see if there is any other question. No, this is file related question. So question for this paper are ended. Let's find out more questions. All right, this is paper 4. Although paper 4 does not fit in AS, but the thing is that this bubble sort topic is common among paper 2 and paper 4. So there was a question which is actually a question which needs your attention. It will be a good question for practice. That is question 2. Let's solve question 2, which is related to bubble sort. Now, this question says that the array item list 1 to 20 stores data. A bubble sort these data. Complete the pseudocode algorithm for a bubble sort. So maximum index is 20. So it means that this 20 is actually upper bound. Number of items is equal to, since this loop is running 1 to number of items, and we know that this should be at least 1 less than the upper bound. So we can make this number of items is equal to maximum index minus 1. So for outer count goes from 1 to maximum index minus 1 or number of items. Since number of items is updating over here, we cannot use it in the loop because that will actually affect the loop. So let's make it maximum index minus 1. So for inner loop is equal to 1 to number of index, 1 to number of items. If item list inner is greater than item list inner plus 1, it is checking itself with the next element, and then temporary is equal to item list inner, and then item list inner is equal to item list inner plus 1, and item list inner plus 1 is equal to temp. This is bubble sort. Number of items is equal to number of items minus 1. Remember, this is how it was mentioned in the book. Since the author of the book, Helen Williams, is actually our chief examiner, so it is a good idea to solve questions and to observe algorithms from the book. Most of the times, if you see, because Helen Williams is the writer, the author of the book, and she is the chief examiner, questions do appear as book. So she is inclined towards the questions as mentioned in her own book. So next part, explain why the algorithm in part A is inefficient. Now, the thing is that I told you that there should be a flag. Now there is no flag in it. So if there is no flag in it, we have to write that iterations will continue, loop will continue even if the array is sorted. That is why we call it, it is inefficient. It is efficient in a way that it is reducing the number of items to be compared and swapped, but it is not efficient in a way that it is checking that if the array is already sorted, so it should get out of the loop. There is no such thing in it. All right. So explain how would you improve the efficiency of this algorithm. Simply, this is how many marks? 3 marks question. So we gonna write that we will use the flag for the indication if any of the swaps have taken place. If the inner loop is completed and there is no such swap happened, then the flag will not be set and it will remain false as it was set earlier. And after the ending of inner loop, we will check if the flag is unchanged. If it is unchanged, then we will break out of the outer loop. That is how we will make further efficient. Now, that's it for this question. Let's find out if there is any more. Another question, same from paper 4, related to bubble sort. This is May-June 2018, paper 4-2, question number 3. In this question 3, October-November 4-2, 2018, a bubble sort algorithm is used to store an integer array list. This algorithm can process arrays of different lengths. So write pseudocode to complete the bubble sort algorithm. So for outer is equal to, uh, we need to find the length of the array. So let's say the length is arrived in some sort of pseudocode or we can use the function length for that as well. So let's take function length or the maximum value. For outer is equal to upper bound minus 1 to 0 step minus 1. Remember, this is A2's paper, so the lower index is lower bound is 0. So for inner count is equal to 0 to outer minus 1. Now, the name of the array is list. If list inner is greater than list inner plus 1, then temporary is equal to list inner is equal to list inner plus 1, and list inner plus 1 is equal to temporary. Now this is completed. Now what it says further, let's see. State the order of the sorted array. This is ascending order. As this is here greater than, it is ascending order. If the previous value is greater than next value, then the next value will come before the previous value. That is how it makes ascending from lower value to the higher one. So state which line of the algorithm would you change to sort the array into opposite order? Obviously here, instead of greater than, we will use less than. In that case, if the previous value is smaller than the next value, it will swap. So bigger value will come first and smaller value will go afterwards. So that will make the whole array inverse. So which line number is this? Line number is 3. And the change will be if list inner is less than list inner plus 1. All right, so let's see further. Use pseudocode to write an alternative version of the bubble sort algorithm that will exit algorithm when the list is fully sorted. So now they are asking us for the use of flag. All right, so use of flag. So now we will be writing an algorithm with the help of flag now. So so let's make this flag swap is equal to false, and then let's make their own way. Outer bound is equal to upper bound minus 1, and then we have to use an alternative way. So let's use repeat or while. We can use while as well. So inner is equal to 0. Swap, again we have to make it false, because before every inner loop we would have to make it false, and we will have to check after inner loop if it remained false, and then inner loop repeat. So this loop will go on if list inner, we have made inner 0 because the lower bound is 0, inner is greater than list inner plus 1, then we will use temp temp is equal to list inner list inner is equal to list inner plus 1. This bubble always remains the same. And then list inner plus 1 is equal to temp. But you need to understand that a swap has happened. So we have to update this swap is equal to true. Now, and if we would have to now check uh, if let's do it later. First, let's update inner. Inner is equal to inner plus 1. Inside loop ends now, and then we have to end inside loop until inner is equal to outer minus 1. So inner starts from 0 and go all the way to the outer loop minus 1 position. And then we have to reduce outer as well. Outer is equal to outer minus 1, and then we have another until that will kick us out if the swap is equal to false. Still, if it is false, if it has not turned yet to true and it is still false, then it is out. What if it is not false even to the last swap? So in that case, you would have to check that if the outer is reduced here down to 0, means every single position not has just been checked, but even the last position of the last loop of the last turn are actually being swapped. So or outer has now got down to 0. In both of the cases, this loop will be working. So at any given point, because of this flag, if the array is sorted in between, so it will not work. Or in other case, if it is quite haphazard and to the last minute it was swapping, then outer when becomes 0, the loop will be breaking. All right. So this is another array related question from May June 2019, paper 2-1. This is question number 3. It says that a student is developing an algorithm to search through 1D array of 100 elements. Each element of the array, the name of the array's result, contains a real value. If it is a real value, then we would have to actually look for numbers which are having decimal places. The algorithm will output the average value of all the elements and the number of elements with a value of 0. So they have given us a structured English. Now this is another way of expressing the uniqueness of algorithms, but this does not describe any declarations and initializations and loopings in terms of pseudocode. It is simple code. You have to remember that you might be asked for structured English as well. So you don't have to actually initialize and all in structured English like we do in pseudocode, but these are simple English statements. So let's see how do we convert these statements to structured English. It says that write the pseudocode for it. So let's write pseudocode for it on a screen. So it says set total value to 0. So let's make total is equal to 0. Set 0 count to 0. So let's make it 0 is equal to 0. 0 is a variable, or let's make total value or 0, whatever that you like. Select the first element. So this is like for index is equal to 1 to 100. And then we have to set the total first. Total is equal to total plus what is the name of array? Result. Result first index. And then we have to check if the first index is add the value of element to total, and if element value is 0, then increment 0 count. So if result I is equal to 0.0, since it is a real number, we have to check if it is 0.0 or maybe another 0. So if the value is like 0.5 or whatever, then we make this variable 0 here. Then 0 is equal to 0 plus 1. We counted it, and then next I. If element value is 0, then increment 0 count. Repeat from step 4 for next element until the last element. So next I. Set average to total divided by 100. So average is equal to total divided by 100. And then it says that output suitable message and average output suitable message and 0. So output average is equal to comma average variable, and output total is equal to total. There we go. This is a simple question. I'm sorry, I think while I was writing, it was not appearing on the screen. So let me just revise it for you. Uh, you can see that it says that set total value is equal to 0. So it has made it 0. Set 0 count to 0. We have done it over here. Then select the first item. This is how we have selected a loop to start with. Add value of the element to the total. That is how we have done it. Total is equal to total plus result I. Result is the name of uh, the variable, I mean the array. Then if element value is 0, we have checked it here. If result I is equal to 0, then 0 is equal to 0 plus 1. They wanted us to increase the count in the 0. And then it says that repeat steps 4 for next element until the element last. So we have done it here with for and next. Set average value to total divide by 100. We have done it over here, and then output a message. Output average is equal to average, and output suitable message and 0 count. So we have actually done it properly. Do check out the marking scheme for the code. It is there, I believe. This is just for your understanding that how we actually convert structured English to its pseudocode. Let's see what it further says. The student decided to change the algorithm and implement it as a procedure, scan array, which will be called with 3 parameters. Now, scan array average value 0 count and array name. Scan array will modify the first two parameters so that the new value are available to the calling program. Right, acha. It means that we'll modify the first two parameters. It means that these are being called using by ref. And array name is being received as by val. So array name was result. So this will become procedure scan array by ref average value as real by ref remember to put this underscore when you are continuing the same statement in the next line. That is how it is done. Zero count as integer and array name is what result. By well they don't prefer. There might be chance that this particular line, the last one, may be different in CIE. Anyways, uh, you will get marks for it. All right. So let's see if it is finished. Yes, it is finished. Now, viewers, this was the last thing. Actually, if you do remember, they said that your program should be in a language. I described programs in language. They should be in pseudocode. We have discussed so many pseudocode. And the last thing that they said that is structured English and the flow chart. So we just have seen that how structured English works. And now let's do a question which is from the recent paper by June 2019, paper 2-3, which is related to the flow chart. So let's discuss that question. Now, this is question number 1. It says that following pseudocode searches for the longest run of identical characters in the array message. So that is how it is given. So let's make a flow chart for this. Flow chart for this particular. It says that draw a program flowchart to represent the procedure search. Variable and array declarations are not required in the program flowchart. So that is also the case. These are not required in the program flowchart. So declaration is not required. We know that there are 4 basic shapes which we have to actually use. First one is start stop. Then we have assignment process. Wherever there will be an assignment, the process will be used, and then condition for any case, and if we will be using this condition box, and then we have input and output in a parallelogram. This is for IO. So let's start. Declaration is not required, so we are starting with start. Then we go further, and what it says, this character is equal to message 1. I make it 1. So these are all assignments. So these assignments will go there 1. And then for index is equal to 2, since there is no particular shape for this loop index, we will only be assigning 2 to index to start with, and then we go further and we see how do we actually deal with it. So this is 2. Then it checks if message index is equal to this car. Is message index is equal to this car. If it is true, it goes on right, and if it says no, it goes straight. Let's make it, this is true. Let's say we use word yes there. Then this run is equal to this run plus 1. So this is 3. Then this run is equal to this run plus 1. This is 3. And then in else case, it says that this is 4, which is no. And then this if will come after 4. If long run is greater than, if this run is greater than long run, if this run is greater than long run, if it is true, yes, then long run is equal to this run. This is 6. If it is not, it goes directly here. No. And then afterward, this run is equal to 1. This is 7. And then this also ends. And then we have end for. Now, we have to run this thing until index is equal to 100. So we have to increase index. All right. So it says that index is equal to index plus 1. And then we have to check if index is greater than 100. Is index is greater than 100. If it is yes, we go out. If it is no, then we have to get back to here. If it is less than or equal to 100, it goes back and the whole procedure will be repeated inside for and next. And then when it gets out, it gives you a parallelogram for output, and then it ends. Stop. Remember, you have to practice several flowcharts. Otherwise, it will become tough for you to translate. So do find out few of the pseudocodes and try turning them into the flowcharts. If you would do that, that would be a good thing to go about. Otherwise, this will become troublesome for you to deal with the flowcharts, making flowcharts from the pseudocodes. Now, there is another question from October-November 2017, paper 22. This is question number 2. It says that 1D array class name of type string contains 100 elements. The following pseudocode represents a simple algorithm to process the array. As we can see that it is inputting a value here, then making the found flag false. Clearly, we are going to deal with an algorithm of the array for searching, and this is linear searching since index is also increasing one by one. So while index is less than 101, obviously increasing one by one, and it will work from 1 to 100. So they have made it 1, and this will be increasing one by one, and loop will run whenever the index is less than 101, which means until 100, or the found flag is equal to false. So until the found flag is false and index is less than 101, this loop will work. So first the search value will be entered, and then this will be searched through the array in every loop. This is not for next loop, this is while and while loop. So you have to understand that in for next it is count based, so it counts itself. But if it is while, then we have to actually increase the count by ourselves. So rest is same. At any given point, if it finds the value which is being searched, it outputs the value and make the found flag true. So that at the end, if the found flag is false, they could tell that it is not found. It is exactly the way we have discussed it in the introduction of array. Describe the purpose of the algorithm. I have explained that this is searching and also using the flag so that it could output proper message towards the end. So draw a program flowchart to represent this algorithm. You do it yourself. Now let's solve a bit complicated question. This is question 3 of paper 9608 23 from June 16. This is question 3. Let's solve this question. This question says that string encryption was implemented using a simple character substitution method. A function decrypt is needed to reverse the encryption process and return the original character. The encryption uses 7-bit ASCII value for each character. This value is used as an index for the 1D array lookup, which contains the substitute character. Lookup contains an entry for each of the ASCII characters. This function decrypt will accept two parameters, a single character cipher character and the 1D array lookup. The steps involved decrypt are as follows. Search for the character in the array. Note the index value where the character is found. The index value is the ASCII value of the original character. Use the index value to obtain the original character. Remember, the thing is already decrypted. So we have to actually, already encrypted, we have to decrypt it. All right. So the first attempt at writing the pseudocode for the function is as below. Now what is happening? If you have to understand it first that what is actually happening so that you could answer properly. So now what is happening is that this function will receive a character, and it says that the character is actually um, the cipher character. Cipher character will be received. The cipher character is received. Cipher character. All right, here it is written. So cipher character is received. Then we have to search for that cipher character. Suppose that cipher character that is received is equal to B. So we have found B here. So we will take this ASCII character 69 and actual character will be the character for this index. So this will be E. Actual character is E. So B is received as cipher character and it is now decrypted as per the ASCII. So now what is actually happening? String encryption was implemented using a simple character substitution method. A function decrypt is needed to reverse the encryption process and return the original character. The encryption uses 7-bit ASCII value for each character. These indexes are actually ASCII values. The value is used as an index for the 1D array lookup. This is array lookup, which contains substitute characters. Lookup contains an entry for each of the ASCII character. The function decrypt will accept two parameters, single character, cipher character, and 1D array lookup. The steps involved in decryption are as follows. Search for the character in the array as we have searched for B. Note the index. We have index 669 there. Where the character is found, and use the index value to obtain the original character with the help of the function that turns index into, ASCII into the character. So let's solve this. This is easy question. Now, this function is decrypt. It is accepting two values and returning the character. So the first value is lookup, the array, the name of the array, lookup. All right, and the second value, it is an array. And the second value is the character which needs to be cipher character, which was actually a character. Now it returns a character. Declare found. Found is a flag, so it will be initialized as Boolean. And then something needs to be declared as well. So let's find what that thing is. Oh, that's index. So declare index as integer and then declare original. Index is equal to 1. Start with the first element of array. Start with the first element of the array. This is what you have to write. This is actually a comment. Found is equal to false. So this flag is being initialized. Now search, start search. Now how long do we have to search? Until two things, or let's just put it to the flag. So until found is equal to false. When the found will be true, it will become obvious that the value is found. So there is no need to go any further. So now if lookup index is equal to cipher character, then set the flag means found is equal to true. Otherwise we have to increase the index. Index is equal to index plus 1. The loop will go on. If you have found, then you know that the index is actually the ASCII character of actual character. So they have made it original character here. So now we have to set the value of the original character. So we would say original character is equal to char of, or maybe just chr would be enough, char of index, and return what? Original character. So this was paper 2.3. In paper 2.2, the reverse of it is there. There we have to decrypt it. Over here, sorry, encrypt it. Here we have to decrypt it. Over there it is to encrypt it. This is a good idea to solve that question in conjunction with this particular question. So this is about us too. Let's just see what was the requirement of the task so that we could conclude this task 2 discussion. So it says in task 2.1, design an algorithm to search for a specific value in the array and output the array index where the value is found. Consider the difference between algorithm to search for a single rather than multiple instances of the value. We have discussed that in very detail and we solve questions for the flag as well. Document the algorithm using structured English. I have shown you structured English, the program flowchart and the pseudocode. We have done it all. They haven't said anything for the program code, but do expect program code there as well. In task 2.2, design an algorithm to manipulate data in an array, for example, sorting. I have described sorting, searching, and a few of the other questions which were dealing with the data in the array in different manners. So users, students, teachers, this is it for task 2. Uh, I hope that I'll be able to make another video for task 3 as soon as possible. Since these vacations are extended, we have no idea when CIE would happen. Um, Try your best to find this way of studies more fruitful for you. Study on time, do not procrastinate, and make sure that whatever that you learn, if you're not making sense of it, do discuss the question, do discuss it in respective groups of yours by asking questions. And if there is anything that you need to know, you may post in comments under this video, or if you are one of my direct student, then please do ask those questions in respective WhatsApp groups. Anyways, thank you very much. Best of luck. Study well, prepare well, do not procrastinate. And whenever there is need of my input, please do ask questions. Thank you very much. Bye. Take care.